Salt attacks steel. Heat expands tiny weaknesses. A structure that looks permanent on opening day can need repair within a generation. Then there are ancient harbour walls that have been beaten by waves for nearly 2,000 years and still refuse to fall. That is the mystery. Did ancient builders know something we forgot? Or did they stumble into a chemistry modern construction is only now learning how to respect? The story begins with volcanic ash. To most people, ash looks like waste after a mountain erupts. To ancient builders, it became a tool. Mixed with lime, stone, rubble, and seawater, volcanic ash could form a material that hardened in marine environments where ordinary construction would struggle. The coastline was not just a job site, it was a laboratory. Here is the strange part. Modern concrete usually treats water as an enemy. Keep water out, seal the cracks, protect the reinforcement. Ancient marine concrete seems to have behaved differently. When seawater entered tiny cracks, it could trigger mineral reactions inside the structure. Instead of simply accelerating decay, water helped create new crystals. Damage became a doorway for repair. That sounds almost impossible, but the evidence is hidden at microscopic scale. Ancient samples contain mineral formations that suggest the material continued changing long after it was placed. It was not dead stone. It was reactive architecture. A wall in the sea could keep becoming itself for centuries. One clue is even stranger: white lime fragments inside the concrete. For years, those white fragments looked like careless mixing, little imperfections left by builders who did not blend the material properly. But what if those fragments were not mistakes? What if they were reservoirs of reactive material, waiting for cracks and water to activate them? This is where the ancient hack becomes uncomfortable for modern thinking. We often assume uniformity is quality, smooth, standardized, predictable. But the old material may have used controlled imperfection. A crack meets a lime-rich fragment. Water enters. New minerals form. The weakness feeds the repair. Ancient builders did not need modern chemistry to observe results. If a harbour wall survived, people noticed. If a pier collapsed, people noticed that too. Knowledge moved through hands, workshops, coastlines, and generations. The experiment lasted centuries, and the punishment for a bad recipe was public failure. The recipe was not one magic ingredient, it was a system. Volcanic ash from the right source, lime, heat, seawater, aggregate, placement, and time. Remove the context and the secret becomes harder to copy. That is why the story is not as simple as saying, just build like the ancients. Their material worked with its environment. Modern construction has different pressures. We build fast. We standardize. We optimize for schedules, budgets, supply chains, and building codes. A material that cures slowly or depends on local geology may be brilliant and still inconvenient. Sometimes civilization does not choose the longest-lasting solution. It chooses the solution that fits the invoice. That turns the concrete mystery into an economic mystery. Who benefits when structures last for centuries? Who pays for patience? There is also a climate question. Cement production today releases enormous amounts of carbon dioxide. If ancient-inspired materials can reduce emissions, extend lifespan, or use lower-energy chemistry, then ruins become more than ruins. They become prototypes. The past becomes a research lab for the future. But the lesson is not that the ancients were magically smarter. The lesson is that they were patient observers. They watched materials behave over long periods. They adjusted recipes to place. They accepted that nature could be partner or destroyer, depending on how the structure was designed. That mindset may be the real lost technology. Not ash, not lime, not seawater alone. The lost technology is designing with time instead of against it. There is something almost human about a wall that heals. A crack appears, water enters, minerals grow. The scar becomes stronger than it should be.
Future cities may need that principle. Seawalls facing rising oceans, bridges exposed to salt, harbors, tunnels, foundations, and coastal defenses ask to survive in a harsher world. The answer may not be hiding in a futuristic factory. It may be written inside an old harbor stone, wet with seawater, and older than entire nations. Progress does not always move in a straight line. Sometimes a 2,000-year-old wall stands beside a cracked modern structure and quietly asks what we missed. And if we are wise, we do not laugh at the past. We take a sample, look closer, and listen.